Welcome to my presentation. In this presentation, we shall see some simple examples related to limits. Let's take an example here. In this example, we want to find the limit of a function. Let me write this here. The limit of the function x squared plus 1 as x approaches 1. As x approaches 1. As a first step, what I want to do is be able to graph this function. If we have a function like this, f of x is equal to x squared plus 1, as we give values for x, the function is going to change. So if I were to construct the table of values like this, x on the first row like that, and then f of x in the second row, and then in here we're going to substitute the values of x as we go. So we will see, let me extend this table here. Let us say when we substitute the value of x as equal to 2 in this function, the value is going to be equal to, the value of the function is going to be equal to 5. Negative 2 raised to the power of 2 plus 1. Negative 2 times negative 2 is a positive 4 plus 1 is equal to positive 5. When x equals to negative 1, when we substitute the value of x as equal to negative 1, the value of the function is going to be equal to 2. That means negative 1 raised to the power of 2, which is going to be equal to positive 1. Positive 1 plus positive 1 is equal to positive 2. When the value of x is equal to 0, when we substitute the value of x as equal to 0, the value of the function is going to be equal to 1. And then we'll pick some points on the positive x-axis. When the value of x equals to positive 1, the value of the function is going to be equal to 2. 1 squared plus 1, 1 squared is equal to 1 plus 1 equals to 2. So the value of when the value of x is equal to 2, 2 squared plus 1 is going to be equal to 4 plus 1, that is going to be equal to 5. So this is how we construct the table of values as far as the graph is concerned. If we were to look at how the graph is done for this situation, we can draw the x and y ordinates, a graph of this nature. This is the origin, this is the positive x-axis, this is the negative x-axis, this is the positive y-axis, and this is the negative y-axis. And if we were to pick some points in here, we have positive 1, positive 2, positive 3, and then we have negative 1, negative 2, negative 3, and so on. If we need more points, we'll pick them up. On the y-axis, if I call this as 1, 2, 3, 4, 5, and now we are ready to graph this. When x equals to negative 2, when x equals to negative 2, oh, let me put these points, 1, 2, 3, 4, 4, and 5. So when x equals to negative 2, the value of y is equal to 5. So therefore, this is the point we're looking at. This is the point we're looking at. So this is one point. When x equals to negative 1, we got this one and this one plotted here. When the value of x equals to negative 1, the value of the function f of x is going to be equal to 2. So therefore, this is the point we're looking at. When the value of x equals to 0, the value of the function is equal to 1, which is right there. When the value of x, we got this point. When the value of x equals to 1, the value of y, or the function, is going to be equal to 2. So therefore, this is the point we're looking at. So we'll put a point circle around it. We got this point here, and the last point is when the value of x equals to 2, the value of the function is equal to 5. So therefore that is the point. Let me get another color here, so that way when we join these points, when we connect these points, it is going to look like a parabola like that. It is going to look like a parabola like that. So in here, the thing what we are observing is as follows. We observe from the graph that as the value of the function f of x approaches 2, as the value of the function approaches 2, as x approaches 1. So if I were to come back and then plot it out in terms this way, as the function approaches 2, the value approaches 2 from either side of 1. It is from the positive side of 1 and from the negative side of 1, from the left side of 1 and from the right side of 1, the value of the function is going to approach 2. So we can state this one as follows. The graph, from the graph we can say that the value of the function f of x approaches 2 as x approaches 1 from either side, from the left and from the right. In terms of limits, we can state the same thing as follows. Let us say we can write the same observation as follows. The limit of the function x squared plus 1 as x approaches 1 is equal to, what we're doing here is we're going to substitute the value of x as equal to 1 squared plus 1, which is going to be equal to 1 plus 1, which is going to be equal to 2. So I'm going to put a box around this, and then now what we want to do is we can show we can show this in a tabular manner as follows. If I were to draw a table here, if we were to construct a table of values here, we can show that that as the function approaches 2, for the values x, as the value of x approaches 1 from either side, as follows. So if I were to make a box in the middle of the middle of this box as 1.000, and then here I can write as 2.000, and as I give the values of x, the value of the function changes. For example, very close to 1 on the left hand side, if I were to pick a value of 0.999, the corresponding value of the function is going to be equal to 1.998 on the left side. And on the right side, if I were to pick a point a little larger than 1, for example 1.001, the value of the function is going to change to 2.002. See, when we are on the left hand side, it is very close to 2. On the right hand side, it is very close to 2. If I pick another point on the left hand side as 0.990, the value of the function then is going to be equal to 1.98, very close to 2 but not equal to 2. It is less than 2 here. On the right hand side, if I were to pick a point, and if I were to say, if I give a value of x as equal to 1.010, like that, the function is going to correspondingly change to 2.020, like that. Let us take one more point on the left hand side and one more point on the right hand side. On the left hand side, if I were to pick a point for x as equal to 0.90, the corresponding value of the function is going to change to 1.81. And on the right hand side, if I were to pick a point 1.10, the corresponding value of the function is going to change to 2.21. Therefore, this is, I want to put a box around this centerpiece here and then say as x approaches 2, as x approaches 1 from the left, then the function of x approaches 2, as you can see. Same thing here, as x approaches 1 from, I'm going to write here, from the right. Or I can put an arrow like this, indicating that as x approaches from the right, then the value of the function is going to approach 2 from the right, and that is how we want to understand this concept here. As x approaches from, I'm going to write here, from left, as x approaches 1 from the left, then the function f of x approaches 2 from the left. And as x approaches 1 from the right, like that, then the function of function f of x approaches 2 from the right, like that. As you can see, the numbers 0.9 is less than 0.99 is less than 0.999, and then very close to 1. And on the right hand side, 1.001 is larger than 1, 1.010 is larger than 1.000, 1.1 is larger than all the three of them there. And therefore, as x approaches 1 from the left, I'm going to draw an arrow like that, then the function f of x is going to approach 2 from the left, like that. And same thing from the right as well. As x approaches 1 from the right, then the value of the function approaches 2 from the right as well. So this is how we can solve simple problems related to limits. In my next presentation, we shall see more examples related to limits.